slope of a line. Okay, this is, they call it, you know, a linear equation, which is going to be the same thing. But I focus on the notion of the, okay, the notion of the slope. It's a 2.1, yes. It is, yeah, in your book, they call it the linear equations in two variables, which is going to be the same, okay, the same thing. So this is it. What's going to be the slope? Okay, the slope of a line. Okay, this is going to be the one. We just review quickly that what is going to be, you know, that this slope, if it's going to be a staircase, and if you want to go up, this is the way we do it. Okay, run, rise, run, rise. This is going to be a situation you're going to have. So if you take one of them out, so this is the way you go up. Okay, this is going to be a run, and this is going to be a rise. Okay, so simply the slope is going to be equal to the rise over run. Okay, that's a definition of the slope. But in order to do it, you have to go from the point P to the point Q. Okay, if the coordinate of the P is going to be x1 comma y1, and the coordinate of the Q is going to be x2 comma y2, then you know that the slope M is equal to y2 minus y1 over x2 minus x1. So this is going to be the slope of the line through two points. Okay, so this is going to be the slope. It's going to be the slope of a line through, okay, through the points, okay, through the points x1 comma y1 and x2 comma y2. We're going to work with this formula quite a lot later on. You know that this is going to be the rise and the run. It depends what we're going to do in future for the y. Okay, so you know, if you derive, for example, the bottom one is going to be the time, the different time. This is going to be your different positions. Okay, so a distance over time would be velocity. So it's going to be average velocity later on. So when we get to the function, we define the average value of the function, and we get various application of the slope. And this formula is, and the concept of the slope would be the foundation of calculus. So that's fine to make sure you know it. So 2 points would be given to you, just find the slope for us. You get quite a lot in your books. Just give you one example. We wanted to find, okay, find the slope of a line through, okay, this is going to be through the given points, given points. That's it. So there are 3 possibilities. So the first one is a kind of ordinary one. It's a -3 and 1. And the other point is going to be, okay, -4 and the -5. That's the case 1. And the case 2 is this one. Okay, the case 2 is 1/2, 7. And the other point is a -3 and 7. That's case 2. And the case 3 is going to be this one, -5 comma 2 and the -5 comma 2. Okay, these are going to be 3 possibilities that usually may have. So 2 points are given. We want to find the, okay, find the slope. So you label your points, and we have your formula. You see the formula is here. We just substitute to get the numbers. So we're going to go with the first one. Okay, solution for the first one. So the points are a -3, 1, and the -4, -5. So label this information as x1, y1, and this is going to be x2, y2. Write your formula and substitute. So m is equal to the y2 minus y1 over x2 minus x1, and substitute. So the y2 would be a -5 minus y1, which is 1. Okay, x2 is a -4 minus x1. We get the negative numbers. Make sure you use parentheses, -3. So the top would be a -6. The bottom one is a -4 plus 3, which is going to be a -6 over -1. So the result would be 6. So the slope of the line for the first case is going to be 6. When the slope is positive, means you go up if you like, and the slope is negative, you go down. So positive means you have an increase, okay, and negative is going to be a decrease. That's a case one. Any question? So when you substitute, make sure these double negatives will be taken care of. Okay, that's going to be case one. What is special about case two? Any suggestion? Case two?
It has a fraction.
And something else? You see? They got the same second y component, if you like. So in these two cases, y is equal to 7. What type of line is y equal to the 7? Y equal to the 7 is horizontal line. When it's horizontal line, the slope is 0, and you're done. You see, if you get the formula, you get the same thing. But at this level, we would like you to be able to identify it quickly. Okay, so the second component are the same, so it's going to be y equal to the 7. So y equal to the 7 is horizontal line. When it's horizontal line, you see there is no rise. This is it. It's all a run. So there is no rise. Rise is 0. So in this case, this is going to be the case. So the slope of the line is going to be equal to the 0. So these are the advantage that you should be able to take care of right away. So that's going to be the second case. Okay, the second case, we notice that we can use the formula and get the same answer. But at this level, you should be able to do a little bit more. It's a -3 and 7. The y component is the same all time. So you claim that the line, you see the line y equal to the 7 is horizontal. Okay, it's going to be horizontal. And so the slope is 0. You don't need any formula for this one. Okay, you know that this is going to be the line. You pick the 7 here, and you draw your line. You see? This is y equal to the 7. So the slope is 0 because this is horizontal line. You don't like it, you just call this one x1, y1, x2, y2, substitute, simplify, you get the same thing. But we would like to get it true right away. Any question? So that's the second case. The third case, let's see what is special about this one. You see the point that we have a -5 and 2, -5 and 2, and then we have a -5 and, oh, I give you the same thing. It must be, just change one of them into 12. Okay, -5 and 12. negative 5, 2, negative 5, and 12. Okay, negative 5 and 12. You see in this case, the x coordinates are the same. You see, x is negative 5 and x is negative 5. X equal to negative 5 is vertical line. When it's a vertical, that's the worst case. If you have a vertical, staircase, how are we going to climb? How are we going to go up? It's almost impossible. So in that case, we say that the slope is undefined. This, in fact, is infinity. Okay, so in this case, you are going to note that this is it, the line x equal to the negative 5 is vertical. Is vertical and m is undefined. M is undefined. In fact, m is equal to the positive infinity, if you like. Again, you can use the formula. If you use the formula, the numerator would be 0, and you cannot divide by 0. So this is going to be the xy plane. Negative 5, this is a negative 5. So this is going to be your line. So as you can see, x equal to negative 5 is a vertical line. There is no run. You must go up, 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 which is impossible. So in this case, m is going to be undefined. Any question? This is the way we do these type of things, in algebra, intermediate algebra. I just want to give you something better. So that is the application of this formula. Then we can use it to write the equation of the line. Okay, this is another thing that we would like to know. Okay, question. You can use the formulas, you get the same thing, but this method is much, much better. I remind you the formula for the equation of the line. So what's going to be the equation of the line formula? The equation, okay, of a line. And you know that if the equation, just quickly get that line again, just refreshing your memory, the equation of a line through the point, okay, through the point x1, comma y1 with the slope, okay, with the slope m is given by, what's the formula? Y minus y1 equal to the m times x minus x1. Okay, so that's going to be the formula for the equation of the line, which is very popular, very popular. Again, if you want to calculus, you need this formula all through that course. So a point and the slope would be given, then just substitute to get the result. But this equation can be simplified. So one can, or you should, okay, one can simplify. One can simplify the equation. Okay, and write it or convert it, and convert it into the following form, into the following, following form. You know that the following form is going to be y equal to mx plus b. You're not interested in the names, so you know that this is called what? Point, the slope equation of the line, and this is called the slope y-intercepts equation of the line. But this is, as far as we are concerned, it's just equation of the line. Anytime you use this formula, you have to solve it for y automatically. So if this is going to be the case, the advantage is we can find the m. We say that where m is going to be, is the slope, okay, the slope of the line. Okay, is going to be the slope of the line. So if the equation is given to you, you can find the slope, or if this information is given, you can find the equation of the line. Okay, any question? Problems is straightforward, and a point and the slope would be given. You want to find the equation of the line. So just remind you. Okay, we remind you that find the equation of the line, the equation of a line through a point. You know, the point is going to be -3 and 5 with slope. Okay, the slope of something like -2/3. So this is going to be the case. Straightforward problem. You have a point and the slope, and this is your formula. You just substitute. Okay, label your information first. So it's going to be the solution. So what we have a point, a -3, 5. You can call it P, the point P. You are going to call this one X1 and the Y1, and the slope M is equal to -2/3. Okay, you need the equation of the line, you have the formula. So substitute to get it. So our formula would be y minus y1 equal to the m times x minus x1. We substitute, that gives us a y minus 5. Okay, y minus 5 equal to the m, which is a -2/3 times x minus x1. x1 is a negative number, so -3. You have to simplify. You take care of these double negatives here first. So it's going to be y minus 5 equal to -2/3 times x plus 3. Okay, you have to simplify it. You multiply the -2/3 inside the parentheses and you continue. So that gives you y minus 5 equal to -2/3 x. Then negative positive would be negative. Okay, 3 times 2 would be 6. That gives you 6/3. Okay, but the 6/3 you can simplify it. So that gives you y minus 5 equal to -2/3 x, but minus 2. We add the 5 to simplify it. So y would be equal to -2/3 x minus 2 plus 5. So y equal to -2/3 x plus 3, the final answer. Okay, so it's not a big deal to get these numbers done. Okay, the p is -3 and 5, and the slope of -2/3. You have your formula. You see it's going to be your formula. You substitute, but make sure that when the double negative, just put the parenthesis here, so negative would be positive, and then you have to distribute -2/3 inside to simplify it. Okay, that's the case one. Any question? Again, just to remind you, you're not going to use it in this course, but you are going to use it quite a lot when we get to the next course. Okay, you just need this to get to know it for the application, a couple of cases, but otherwise we quickly, because this gives us a special function. This is the one we need in the next section. We call it a linear function, nothing else. Okay, so that is one case. The other case is 2 points would be given. You find the equation of the line. Okay, so another example. 2 points would be given this time. They want to find the equation of the line. So I would like to find, okay, find the equation. Okay, what's the question? Yes, we can go slower, but these are from algebra. Okay, we want to find the equation of a line. Okay, equation of a line through the points. 2 points would be given to through. Okay, prove points or the points. The points are going to be 2 points. You may be given, let's say, 3 and -5, 1 point. Okay, we have another one. And the other one is going to be the point, let's say 1. Okay, 1 and 3. You see, 2 points are given to you. In order to write the equation of the line, you need the slope. So in order to find the slope, you see we have 2 points. We can use the 2 points formula to find the slope. y2 minus y1 over x2 minus x1. We get the slope, then we have the slope and 1 point. We can write the equation of a line. Okay, so it's kind of two problems in one. That's the idea of this that we are going to consider. Okay, so let's do it. You have to label this information. So that's going to be solution. So label the information. We have 3, comma -5, and you have 1 and 3. So what I'm going to do, I'm going to call this one x1, and this is going to be y1. So this is going to be x2, and this is going to be y2. Find the slope first. Remember the formula for the slope. Rise ran, y2 minus y1 over x2 minus x1. So substitute m equal to y2 minus y1 x2 minus x1. That's your formula. Substitute. You have the values from the given points. So it's going to be equal to y2 is 3 minus y1. y1 is a -5. You have to put it inside the parentheses. -5. Divide by x2 minus x1. x2 is 1. Minus x1, which is -3. Any question? Go on, simplify it on the top. Double negative make it to positive. So it's going to be 3 plus 5. And this is going to be a -2. So we get the 8 over -2, which is a -4. Okay, so m, the slope is -4. Any question? Now we have the slope and we have a point. So we can write the equation of the line. You can use either point, the first one or the second one. But since we already called this one x1 and y1, so we stay with this notation to get to get through it. To get these numbers done. Okay, what's the question? What's the question? How did I get the 3 plus 5? This is it. Negative, negative, positive. That's how we get 3 plus 5. Okay, we just substitute y2 minus y1, x2 minus x1. y2, 3 minus y1. You see, there is a negative here. So you have to put it inside parentheses. Okay, negative, negative, positive, 3 plus 5. Okay, any question? So that's the m. negative 4. Go back, substitute. So what's the equation of the line? This is the formula. Y minus y1 equal to m times x minus x1. Substitute. x1 is 3, y1 is negative 5. M is negative 4. So substitute y minus y1. What's the y1? It's a negative 5. Again, you have to use parentheses. Negative 5. So that's only one. You don't miss these parentheses because that makes it into the positive later. It's going to be m. M is a negative 4. Negative 4 times what? X minus x1. What is the x1? 3. Okay, you just simply substitute these numbers. You have to simplify it. Simplify, solve for y. So we're going to simplify. We take care of this one first. So that give y plus 5. Negative, positive. Then you have to distribute negative 4 inside parentheses. So it's going to be equal to, multiply, go forward. Negative, positive would be negative, so negative 4x. You come back, repeat it again. Negative, positive. 4 times 3, 12. Okay, we substitute and just keep going. So you have to subtract the 5 because you have to solve it for y. So y is equal to, okay, it's going to be negative 4x plus 12 minus 5. Okay, so y would be negative 4x plus 7, and we are done. It's a very popular problem, and you get quite a lot in your book. 2 points are given to you. You want to find the equation of a line. You need the slope. So x1, y1, x2, y2, the slope formula, this is it. Rise, run. You substitute, you get the slope. Sorry, question?
Doesn't matter what point you use.
Doesn't matter. But you must stay, yeah, it doesn't matter. But, if you use the y2 from the second part, you must use the x2 from the second part too. Okay? So that gives you m. Then you can use either points here. It doesn't matter. You can use the first one or the second one. That gives you the same answer. Just substitute y minus y1, m times x minus x1. And you simplify it. That gives you the equation of the line to get these numbers. Any question? So quickly, we review really this part of the idea of the slope for the time being. And because we need to have an equation of a line as our function that we're going to talk about in a minute. There are cases like in algebra, the lines are going to be parallel, perpendicular. We are not going to be interested in. You can read it for yourself because they are not going to use when we get to the function part. But I'm going to explain it for you just to refresh your memory. Okay, any question? So make sure you know these two formula, two famous one. We give one question from this one on the next test. Okay, this is the equation of the line, and this is 2 points formula for the slope. You need only these two equations really to be able to get through this section. Any question? So this is all we need from this section. So we're not going to stay here anymore. Okay, that will take us to the. We are ready to challenge that famous 2.2. Okay, any question? So refresh your memory regarding these equations, and as I told you, we are not going to use it, so we're not going to see it anymore. But the big one is 2.2. Okay, we are going to stay here, and we take it slowly here now, because that was a review. Okay, and sometimes we don't cover it 2.1. When we teach at the university, we don't cover that one. We just go straight on to the to the functions. Now, the functions are the most important part of, mathematics, if you like. Let's see what is going to be the functions. Make sure you understand whatever I'm going to do in this section. Any question, you let me know. I will stop and explain it. Okay, what is a function? There are different ways to define it. So what I'm going to do is, if we go read the history of mathematics, years ago, there were lots of controversial ideas about how we're going to define these functions. But later on in the modern time, if you like, they suggested to define the function using 4 different tools that we are going to talk about it. Okay, the first tool is going to be in your book. They briefly go to the second part, but I'm going to explain it because we need it. So the first tool is something that we call it relations. So let's talk about the relations first. Then that would take us to the functions. What's the definition of a relation? Okay, relations. You see, you know that in everyday life, in order to have a relation, you need a pair. Okay, you are going to relate one person to the other person. So we are going to define a pairs first. Okay, so if 2 numbers are given to you, so if x and y are going to be numbers, it can be things, okay, it doesn't matter. Okay, it can be things, objects, okay, objects or numbers, etc. But we work with the numbers. If x and y are numbers, then if you write x first, follows by y, you see, as a point, this is going to be called an order pair. It's called, okay, an ordered pair of numbers. There is a reason that you put these two together, okay? That reason is the order. Okay, if you have 2 numbers, 1 and 2, you know that an order pair in xy coordinate would be just a point. But in everyday life, x and the y can be anything you like. You see, this is you, x, you, y is your salary. So the pair would be the pair of the u and the salary. If we write this for all the population of this class, so x would be represent the names, the y would be represent the salary. So this is going to be a kind of relation that you're going to have. Okay, x is going to be u, y would be the number of the units that you have. Okay, x is going to be number of the hours that you work, y is the dollars that you make. So this is how we put them together, order pair. Okay, now, if there is going to be a reason that you put some of these together, that result is called a relation. So a relation is a collection of order pairs. Okay, some order pairs that you are very much interested in. Okay, so this is going to be the case. Any collection. Okay, this is going to be the one. Any collection or set, any collection of order pairs. Of order pairs. Any collection of order pairs is called, okay, is called a relation. A relation. Okay, if you put 3 order pairs together, you create a relation. Okay, if you have a relation, the first component is going to be x values. The second component would be y values. If you put all these x's together, you have the domain of the relation. If you put all these y's together, you have the range of the relation, okay? So the set, the collection, the set of all, let's say x values means x's, okay? X values of the relation is going to be what? Is the domain, okay? Domain is the domain, and the set of all y values. Y values, okay, is going to be called, is called the range of the relation. Okay, those x's are going to be called the domain, those y's are going to be called the range. And this is your job. Your job is we give you a relation and you are going to determine those domain and the range for us. Okay, let's give you some examples and then take it from there. So there you are. Example. The following. Okay, the following are relations. Are relations. What's going to be the first one? You see, I call it R for relation. And I put some order pairs together. You see, 1 and 5, 2 and 6, 7 and 8. You see, this is a relation. There is a reason that you relate 1 to the 5, 2 to the 6, 7 to the 8. But they must be order pairs, you see, order pairs. So it's going to be a relation from 1 to 7 to 5, 6, 8. So the first component are going to be domain. You see the domain. Domain. The domain of this relation is going to be a set notation. 1, 2, 7. That's a domain. The x values, we call them the inputs. And the range is the second component. 5, 6, 8. So the x values, we call them the inputs, are 1 to 7. The range, the outputs, the second component, we call it 5, 6, 8. Any question? Can you give us one example of relations in everyday life? Where can you see a collection of these order pairs? Any suggestion? Where do you go in everyday life? Any suggestion? Just think about it. Where do you go? Give us a name of a place that you go, one of them, every day, or sometimes during the day.
Work.
Work, yes. Yeah, work, very good. Work is a relation. Work is a relation. You see the first component, the domain, is the name of the employee. The range, the second one is their salaries. So if you put the name of the employees in your company and their salaries together, you have a relations. It's the relations between the the salary and the number of the hours. That's a relation. More examples of this type of relation. in everyday life? Just think about it, how to put this order page together. Where do you go other than the work in everyday life? You
We can't
drink.
go.
Which one?
So we can't go anywhere. Coronavirus.
You are right. Okay, that's going to be the one. No, in the usual one. Anything else? Okay. Yeah, we go for, yeah, you go to eat. Yeah, where do you go? You go to fast food restaurant. As soon as you arrive, you see relations. What is the relation? You look at the chart. French fries. Okay, how much? $3. Soda. That's the one. Big Mac. Okay, waffle, etc. So they give you the relation up there. You see, you have a look at the chart, and you will, you will see it. So all those fast food restaurant menu, all those menus are relations. You see the menus. The first one give you the name. Okay, a white mocha. Okay, the second one is the price, $4.70. What, it's grandy. And so go to a Starbucks, you see the relations. They put it up there, okay, on the chart. So you go to what, grocery store. As soon as you arrive, you see the chart. You see they put the number of the produce, okay. What's that? Lettuce, watermelon, etc. So you have the number and you have the product. So Starbucks is going to be another relations because they are all order based. You put them together, okay? Since the reason you put them together because they are relationship from Starbucks. So that's going to be the one. So if you think about it, there's quite a lot. Let's give you more example, then we come back to it because it's important for us for the functions, okay? To get an idea and examples. Let's give another one. Then we go on. Let's check this one. Let's see what is special about this one. Yes, you look at this one. This one is going to be, how about 1 and 9, 1 and 10, 1 and 12. Okay, that's the one. Let's say 1 and 20. Look at this relation. It's a relation, is a collection of numbers, a collection of order pairs. So what's going to be the domain of this relation? You see the domain? The domain is the first component. The first components are all 1. So you're not going to repeat it. You just pick one of them. You see, just 1. Okay, this is going to be the domain. What's going to be the range? The range is the second component. The second component is a 9, 10, 12, and 20. So this is going to be the case. Okay, it's a relation. It's somebody that you see, it's a somebody that's related to the other people. It's like your Facebook friends. You see, this is you, and these are your friends. So you are in relationship. So that relation is why you put them together. Okay, so a relation is just a collection of order pairs. We put this order pairs together, and then we are going to have a relation. Okay, relation. Any question? Now, we can stay with the relation forever if you're measuring computer science, they use this type of ideas. But what we are going to do is we are ready to give you the first definition of a function. Now, what is a function that we talk about it? You see, a function is a relation. It's a relation with only one extra condition. The condition is this input. You see this input? X, we call it the input. Each X must relate exactly to one value of Y. Each X value must connect to only one value of Y. You see, these are nice. Look at the 1. 1 is related to the 9 and related to the 10. So 1 is related to 2 values of Y. In this case, this is not a function. This is just a relation. Okay, so In the case of the function, if you write it down in set of order pairs, this first component, they cannot share. They must be all different. So that is the first definition of a function. So a function is a relation. It's going to be a relation. When you say a relation, then you have to define that relation. In mathematics, we define the relation by adding, subtracting, multiplying. So let's have the first definition of a function, then we take it from it. You see, we can stay with this one, but it can be used when you get 1, 2, 3, 4, 5, 6, 10. But how about if I give you 1,000 order pairs? How are you going to list those 1,000 order pairs? You can't do it. So you need a brief formula to be able to do it. And that would be taken care of by the definition of a function, okay? So mildly, this is going to be the first definition of a function, okay? That's the first thing was, suggested for the notion of the function. Just go on internet, just click concept of the function. You'll be surprised. For just this definition, they spent so many years just to talk about it. And there is a number of the report from the Department of Education of the United States of America, just for past 20 years, if you like. They spend so much money to find out why the students in high school and even at the university, they have, they have no good understanding, if you like, the notion of the function. What is wrong? So then they came up with this type of ideas to start with the relation first and take it step by step to the function. Okay, there are some textbooks from the high school, maybe 30 years ago. When you look at it, you will find out the way they defined the function was not correct when we think about it today, okay? But today we have a good understanding. Why? Because this is foundation of science and everything's all right over there, okay? So if you are interested in this type of things, you can check it for yourself. But this is going to be, I teach calculus and at the same time I teach discrete mathematics to the computer science major. So the way they look into the function is different. But we have these different interpretation, and we can stay with one of them with one discipline and one more the other one. Okay, that's why we discuss it first. Then we focus on the case that we are going to be, is going to be applicable to what we want to do. Okay, so you got to be patient. We get to that one, which is in your book. Okay, so let's give you the first definition of a function. That would be very good to get it to the actual one. So what's this definition? Definition is going to be a function. Okay, let's say a function f4 function, is a relation. Is a relation of order pairs, order pairs that we denote by x comma y with one condition. Okay, so it's going to be a relation of order pairs. Okay, this is it. That relates each x value, okay, each x value to one, to exactly, let's say, to exactly one y value. Okay, x values and the y values. Okay, so a function f is a relation of order pairs x comma y that relates each x value to exactly one y value. It's not going to be any repetition, if you like, in this case. Now, in the case of the function, the x values, okay, are called are called inputs, and the y values. The y values are going to be called, okay, are called outputs, outputs of the function, of the function. Okay, so it must be, so if you like, therefore, the definition of the function that we talk about it, okay, so therefore, uh, if f is a function, okay, if f is a function, f is a function, then, okay, there is not going to be, there is no two distinct order pairs, order pairs in f with the same x value. Okay, so the x values must be different. You cannot have any sharing. Okay, if f is a function, then there is no two distinct order pairs in f with the same, okay, x value, or with a common, if you like, with the common first component, if you like, first component. Basically, you check the first component. If they are different, it's a function. Otherwise, they are not. Give example to explain it, then we change it to the other format. Ready for the example? This is your first problem. First problem, we give you one. We give you a set of relation order pairs. Then we ask you to tell us which of those are going to be functions. Okay? So we'd like you to determine if the relation is a function. Is a function. They usually say if so. So this means if your answer is positive, what is the domain and the range? Find the domain and the range. Okay, range of the function. Of the function. Okay, we give you 3 of these, and then we ask you to do it. Okay, usually 3 cases. First case, I'm going to call it G. The name is not important. So this is the first one. Look at this one. We have 2, 5, negative 1, 10, and the 7 and 5. We want to know if this is a function. Remember, you shouldn't have any shading for the first component. You look, you see, 2, negative 1, 7. There's no shading. We don't care about the second one, remember. Just the input. They can share the second component, but they cannot share the first one, okay? You just have a look, you see, There is no sharing. They are all different. So it's a function. Okay, so in this case, solution G is a function. I've given this one on the test. Some people, they miss it. They just, you know, they just focus on the 5. No, first component. No sharing for the first. So G is a function with domain, first component, 2, -1. The order is not important. You can write on as you like. Okay, and the range, second component, 5, 10. You know, when it's repeated, we are not going to repeat it again. Okay, so this is a function because there is no repetition for the first component. So every input is related to one output only. 2 related to 5, -1 related to 10, 7 related to the 5. So in this case, it's going to be a nice function. Any question? That is case 1. And for case 2? Okay, let's see what's going to be case 2. Case 2 is this one. Let's have a case 2. The case 2 is going to be F relation. And you are going to have, let's say, 2 and 7. Okay, we have a -1. Okay, it's a -1 and 10. And we have, okay, we have something like 5 and 8. And then we have 2 and 1. Look at this one. You check the first component to see if they share. You see, look at this one. You get a 2 here, and you get a 2 here. So we have 2 order pairs who share with the same first component. So that's why we reject it. Okay, we reject this one because of this 2. You have to explain it. Okay, we say F is not a function. It's a relation, but it's not a function. F is not a function. Not a function. You have to give us a reason why. Why? You explain is that 2, 7 and 2, 1. They share the first component, have the same, okay, the same x value if you like, or first component, okay, x value. Since it's the sharing, you see, you can't do it. You see, 2 is related to 7, and the 2 is related to 1. You can't have it. You must have a straight line if you like. Okay, 2 can be related only to 1 if this is going to be a function. Any question? So from the relation, it's very easy to identify. Since it's not a function, we don't care. We don't determine the domain and the range. It's, of course, it's a relation, okay? It's a relation, but it's not going to be a function. Question? We should give another one. This next one is a special. We use it from time to time, so I want to make sure you don't miss it. Okay, this is it. Call it H. And the H is going to be equal to the 10 and 1, 2 and 1, and the 3 and 1. You see? The second component are the same, not the first. Second is all right, not the first one. Okay, so there is no sharing. So this is a nicely a function. So H is a function. It's a function with the domain of the function. You see the domain? The domain is what? is 10, comma 2, comma 3. That's the domain, the first component. The range, the second component. The second component is only 1. Okay, it's going to be only 1. Can you give us an example in everyday life of this relation? Ten, 1, 2, 1, 3, 1 are all 1, 1, 1. Example of a relation in everyday life. Like a dollar store. You see, everything is $1. Soda, $1. Fries, $1. $1. So it's going to be called a constant function. And this is going to be like your friends and you on the Facebook. Your friends and you is a function. But you and your friends is not a function. That's interesting, okay? Your friends and you, because they are different. You have different friends. But if you switch it, you are going to be at the first component, so you are not going to be a function. Okay, so this is a function and relation, okay? It's good, but it's good for the finite case, you see. 1, 2, 3, 4. But in everyday life, okay, in mathematics, you are not going to have 4 and 5. You are going to have infinity many. So we are ready to give it a definition. I give a break, we come back, and we take that one. Okay, any question? It's 8:26, 10 minutes. We come back and we get the nice part. And this section is very dense. It will take us to all the okay, the time of the next lecture too. Yes, pay attention. It's a very good section. Okay, 10 minutes, we come back. Okay, we're going to continue. So far what we did is we just define a function as a relation. Okay, the relation between x and the y with one condition. The condition is if you give x one value to the function, okay, one value of the x, you must be able to connect it to only one value of the y. So you cannot have any repetition for the first component. So that give it a function. This type of notation is going to be good, but if you want to use, all real numbers, it's not going to be practical if you like. So we're going to write it down in abstract form if you like. In algebra, we like formulas. So the formula format of the function is going to be, you're going to call it, in your book they call it function notation, but I'm going to call it function machine. We look at the function as a machine. So what's going to be function? Okay, function machine or function notation if you like. Function notation. Okay, what we are going to do, remember, the function is the relationship between x and the y. So where is the function is coming, you see? X is going to be the input if you like. So you pick one x, you want to relate it to the y. In order to find that relationship, you have to drop it into the function machine if you like. You see, this is going to be your function machine. What is the action of this machine? You see, this machine can be a calculator. Okay, this machine would run some formulas. So that machine would apply to the x, that formula. We may multiply by 2. We may square it. We may take the square root, take the cube root. So whatever this machine will do, give us a result. So this is going to be the action of the machine on x. This action of the machine on x is the one we call it y. Okay, so x is related to y. X is related to y. What is that relationship? This is a relationship that we're going to define. Okay, the condition is if you drop x into the machine, one x into the machine, you can get one y out right away. The best example of this format is the cashier machine. So you go to the cashier, you see this is the cashier. Inside the cashier, there are different formulas. You scan the soda. The cashier machine would bring the soda machine, soda function. They charge you y. Okay, so x is the soda, they bring the formula and they charge you. Then you scan the next item. The next item, fries. So the machine would bring the fries function and they charge you. So all the cashiers are functions, okay, are functions. Inside the formula is already been designed. Okay, so this format is very practical and it can be used in everyday life. So this is going to be how we're going to define this formula. We're going to say that a function, okay, a function f is a machine. That machine maybe is a relation, maybe an equation, okay, maybe a formula, okay, a formula, maybe a chart, like a Starbucks, Burger King, etc., or maybe a graph, or a graph. Okay, these are all the possibility for your machine. A relation, an equation, a formula, a chart, a graph, or all of them with one condition. What is that condition, you see? So F is a relation, this is it, that whatever it is, that relates each x value, remember x value, to one and only one and only one y value. Remember, one. Okay, so we drop the x in, we get 1y out. This y is going to be denoted by, you see, y is denoted by f of x, action of the function on x. And in this case, this relationship y equal to the f of x is going to be called, okay, it's called the equation of a function. The equation of the function. So this is a format that we like in algebra, a machine. So that machine is a mathematical machine. A mathematical machine can operate mathematical operations, adding, subtracting, multiplying, dividing, taking the square root, the fourth root, the fifth root, all the action that this machine can do for us. But always one condition. You drop one x, for each x you get only one y out in this machine. Okay, you pay $5, you may get one fries. They are not going to give you two fries, okay, because you paid $5. For each $5 you get only one fries. So this is why this is a function. Okay, so this notation is better, the function notation. So let's focus on this notation to see what type of function are you going to have. Any question? So we just take it step by step to to get to the format that we're going to be interested in. And previously we give you some relations and we ask you whether they are a function. Now we give you some equation and we ask you the same problem. This is your second problem, and you get quite a lot in your book. Okay, so what is going to be the second problem? The second problem is I give you an equation between x and y. Then you tell me that if this equation can represent y as a function of x. Okay, so we'd like you to determine, tell us, determine whether or if, okay, whether the equation, represent whether the equation represents y as a function of x. Y as a function of x means I give you x, you give me y. If I give you one x and you can give me only one y, this is a function. Otherwise, it's not. Okay, are you ready? The first one is straightforward. You say I give you y equal to 3x plus 5. You see, I give you one x. What are you going to do to my x? You multiply by 3, you add the 5. So if x is equal to 1, you are going to have 3 plus 5, which is 8. You give me 8. If I give x equal to 2, you say 2 times 3, 6, and 5, you give me 11. So as you can see, I give you x, you give me y. For each x, I get only one y out. So this is it. This is going to be a function. Okay, it's a function because it's already solved for y, and the y is already given to you. Okay, so order page that we are going to have, I give you x, you give me y, and then you're done. Okay, that's the first one. Any question? How about the second one? Look at this one to know the difference. So what's going to be this one? This one is going to be, we have the, let's say, x squared plus y squared equal to 16. Okay, we want to know if this equation is a function. So you have to solve for y to see what would happen to the y. Okay, so the solution for this one is going to be, so this means, it's a function. So this y is a function, function of x. Because I give you one x, you give me one y out. Now this one, we have to find the y to find out. Okay, solve for y. Solve for y. So this means you isolate the y, it's going to be y squared equal to what? It's equal to the 16 minus x squared. You want to find the y. How are you going to find it? Any suggestion? To find the y?
Square root both sides.
Very good. Square root of both sides. It's going to be y squared, okay, equal to the 16 minus x squared. What is radical y squared?
Y. Absolute value.
No. Excellent. Absolute value. You see, that's it. Remember, you want to drop the absolute value. We talk about it. You have to pay for it. So it's going to be pay positive negative. 16 minus x squared. You see, I give you one x, but you give me two y's. So this is not a function. You see why? Because I give you x, you give me y, which is 16 minus x squared. Then I give you x, you give me another y, 16 minus x squared. You see the shading? So they shade the first component. Remember, no shading in the case of the function. So this means y is not a function, okay? They shade, if you like, okay, they have, if you like, just for your information. Okay, the first component are the same. Okay, this is it. They share the first component, or that's it. There is a common, okay, x value. Just for your information, okay? So y is not a function of x. Okay, and then we're done. In future, not for this test, we wanted to check it for us. As soon as you see the y squared, is not a function. You're done. Because y squared, you know that eventually you have to take the square root and give you two solutions. So for 1x, you get two y's, it's out. It's not a function. That's okay. We want to check it really to get these numbers to understand it, that they share the first component, because you could drop the x. If it was y cubed, it's fine. If it's going to be y cubed, you see you take the cube root. You are not going to get the positive negative. So the difficulty is just the even power of the y. If it's happened to y to the fourth, y to the sixth, y squared, it's not a function. Okay, any question? So we give another one. You see this one? This is going to be, suppose we have a 2x, okay, plus y equal to 12. You see, that's easy. We solve for y. Let's have y cubed so that you know that. Okay, solution. Solve for x. Solve for x, so that gives y cubed equal to 12 minus 2x. Take the cube root. You see cube root of y equal to cube root of 12 minus 2x. But cube root of y cube, sorry. The cube root of y cube is y. It's not absolute value of y. There is no positive negative, you see. It's a function. Okay, because I give you y, you give me, I give you x, you give me y. So y is a function. Y is a function of x. Any question? So you have to worry about the power of the y. Okay, and there is one more case that you have to worry about. Any question? And that is the case. I give you two so you'll be able to compare them together. You see number 4 is this one. Suppose you have the y plus absolute value of x equal to 1. And that's clear. You solve for y. Solution. see, so for y, solve to for y, it's going to be y equal to 1 minus absolute value of x, which is fine. We give 1x, you give us y. It's not y square. It's not absolute value of y. Okay, so this is a function. Y is a function of x. Any question? But if you switch it, see how about this one? See this one? You have to solve for y. So what's going to be the result? Okay, solve for y. If you solve for y, that gives absolute value of y equal to the 4 minus x. Okay, you want to drop the absolute value, you have to pay for it. The pay is positive negative, you see? I give you x, you give me 2 y's. So this means y is not a function, okay? So y is not a function of x. Okay, in general, if the value is just for your information, but on the test you have to do it for us, it's just for your information. In general, if the equation contains absolute value of y, or something like y squared to the 4th to the 6th, then y is not a function of x. Function of x. This is quick way, to know it in advance before getting it. Okay, any question? So as soon as I give you, the next one, you know that the y equal to this from your book, you see, 3x plus 1 over x minus 2. Doesn't matter. I give you x, you give me y. The formula is already there, so it's a function. So you have a list in your book, in your assignment. They listed some equation, and they ask you just check if there is a y square, solve for y to get the positive negative. If there is an absolute value of y, solve for the absolute value of y again to get a positive or negative, so that then you can reject it right away. Okay, any question? So that is one version of the definition that we are going to have. We have quite a lot. So what else can we do? Remember, if a function is given to as a relation of those order pairs, let's pick some functions in everyday life in this format as a machine. Do you have any example? I told you cashier machine. All of them are function. Anything else? Have this format of the equation type, if you like. Can you think about it? Other than the cashier for everyday life? The good one is your calculator, you see, calculator. Calculator is a function. It's a very good function. You see, your calculator is got several functions in it. So when you work with your calculator, you see you have several functions in there. All these are functions that we're going to apply. Okay, so for example, if you put the x in your calculator, okay, and if you click on the absolute value, the square root, you see, So that's a square root. If you put the x in the square root, if you put the 4, okay, then you click, so that give you 2. So if I put x, okay, this is it. This is the square root function. So the result would be radical x. You see y equal to the radical x is a function. Okay, we call it what? We call it the square root function. Is the square root function. So it depends, okay? It depends what you click on, if you like. So your calculator is a function with several machine inside it. Okay, can you give us any example in everyday life? You think about it as a function. We talk about those cashiers, you know, fast food restaurant, grocery store, all of them are going to be, you know, that cashier would take care of it. How about gas station? You see, if you go to the gas station, gas stations are very nice function. So what do you see on the gas station? You see, you select the type 1, whatever gas do you want. So the machine nicely give you the money, give you the formula. Remember, X is the number of the gallons. X is the number of the gallons, and the machine will calculate it, and they ask you for the money. You see, they ask you for the money. So it's a number of, okay, this is going to be number of the gallons, and this is dollars. Okay, they charge you. So it's a nice function, okay, or the gas stations are nice function, and we see it as they, you know, as they operate. We got these numbers right away. Somebody say casino, okay, yes. Vending machine. Vending machine is going to be a function. Okay, the vending machine is a very nice function, in fact. The vending machine is a function. The other one is that you don't like it, the tax machine. That's a good function. We talk about it later. Because tax machine is different. You see the tax machine? How are going to be taxed? So it depends on your income. If your income is between 0 and let's say $30,000, okay, they bring the 10% machine. Okay, 10% of your income. But if your income is going to be higher, okay, it's going to be higher, let's say $1,000, they bring another machine, 20% machine, etc. So the tax machine is a tax function. Okay, tax function. It's a very good function. We call it piecewise divine function. We talk about it later. You see the tax machine. The other nice one for calculus is post office. Okay, that's going to be the post office function. That's a very good one. So what do you do in the post office? Okay, let's call it W of X. You put the parcel on the scale, remember? You have to put it, see, on the scale. If it's going to be something, let's say between 0 and, okay, between 0 and, what's that, 2 ounces, 3 ounces, then you have to forever. You have to pay, what's that, 53 cents now? But if you have a heavier one, okay, heavier one, let's say that, you may pay something like, you know, $2.50, etc. So that's a very nice function. These functions are the one that we use in science. These are the functions that you cannot define by one equation. You have to apply several equations, okay, to get, you know, to get these functions. As you can see, they are all over the places. Any phenomena that you think about it, at the end of the day, the formula that you're going to apply is the function. So that's why it's such an important concept. The difference between college algebra and intermediate algebra is just this concept of the function. Okay, so just think about it. the everyday life, everything you do, okay, everywhere you go, there is a kind of function that you're going to know, you're going to apply. Okay, any question? So just think about it. That will help you to get a better understanding of this function notation. Now, the other problem that we have to challenge, one of the many problems that we are going to do, you have, okay, is going to be, so if it's defined by a relation, okay, we pick the first component. Remember, that gives us a domain of the function. But how about in this format? If it's giving you as a machine, how are you going to determine the domain of the function? And that's still, this is the third problem, which is very important problem. If you take calculus, during the first week of calculus, I usually focus on this example. Okay, so what is this example? You're going to have it through the course. Okay, this example, when we learn more functions, we are going to bring it again. And this is we want to find the domain of the function from this equation. So find, as I told you, this section is very dense, very. Okay, let's take this one too. Find the domain of the function. Domain of each function. Remember, the domain is x values. The x values that can go through the machine. Those would be the domain of the function. You see, x is a free agent. It means x is a variable. Since it's a variable, x can be any real number. So x can be anything between negative infinity and positive infinity, unless the formula of your function would put some restriction on the x. So this is how we're going to investigate. There are 4 types of function. Okay, there are 6, but we are going to learn 2 of those at the end of the course. So what's going to be the first one? You must know them by name. Okay, this is it. F of x equal to, okay, f of x equal to the 5x cubed, okay, minus 3x squared. 3x squared minus 7x, let's say plus 7x, and the plus 10. Look at this function. This function is like a calculator. You put the x to the function, and this is what they are going to do to your x. Okay, so what type of operation are going to use? They are going to use addition. They are going to use multiplication, 7 times x. Exponent is like multiplication, it doesn't matter. And you use subtraction. So this machine, this calculator, this function would operate addition, subtraction, and multiplication to your free agent. Your free agent x is just a number. So you want to add, subtract, and multiply the numbers. You know that there is no restriction. We can add, subtract, multiply any number we like. So the domain of this function is the domain of that free agent. All real numbers, from negative infinity to positive infinity. So as long as you add, subtract, and multiply, it's free. We have a special name for this function. Do you remember this function in algebra? In algebra, it's a combination of powers of x, you see, x cubed, x squared, etc. A combination of powers of x is called, anybody?
Polynomial.
Polynomial, very good, polynomial. So we are going to call it a polynomial. There's going to be one more chapter we talk about the polynomials, but we better know it now. Since it's a polynomial, it's defined everywhere. Okay, or as I talk about it, adding, subtracting, and multiplying. So this is the way you are going to answer it. Say solution. You just mentioned that the f is a polynomial. F is a polynomial function, if you like, and is defined everywhere. is defined everywhere on R, real numbers. Okay, so you see the number line? Everything here. In short, this is the way you can do it. In short, you say f is a polynomial. F is a polynomial. And so the domain, all real numbers. You're done. You can say all real numbers or negative infinity and positive infinity. We accept both. Or you can say D is open interval of negative infinity and positive infinity. We accept both of them. That is the type 1. Any question? So polynomial, you see, x squared minus 3x plus 1 is a polynomial. X to the 5th minus x to the 4th plus 1 is a polynomial. So polynomials, okay, combination of powers of x. That is the first category. Any question? Ready for another one? Another one is a rational function. What is the rational function? You see, this is where you are going to divide. You see on the top we have, let's say, 3x plus 1. Down the bottom we have x minus 5. Look at this one. So what type of operation your machine is going to do for us? Adding, subtracting, multiplying 3 times x, and dividing. Anytime you divide, you got to be careful. You know that you cannot divide by 0. So you have to guarantee that, so x is not going to be free agent anymore because there is a restriction. What is that restriction? You see the denominator? This is x minus 5. If you put the x minus 5 equal to the 0, that gives x equal to 5. So this function can take any number, but not 5. Okay, so for your solution, you have your number line. You see this is your number line. You have to take this 5 out. 5 out. Because your function is not defined on 5. So what's the domain of your function is 2 partition. 2 partition. So the domain is, you start from negative infinity, you arrive at 5, union with, you start with the 5, and you go to the positive infinity. How we find out? You see you did x minus 5 equal to the 0, so that gives x equal to 5. So this function is defined everywhere except at x equal to 5. Of course, we like interval notation, okay? You are going to use this type of notation for us. Okay, if you like it, g is a rational function. If you want to know the name, we are going to have one chapter on this one. G is a rational, okay? Rational function. So when you see the division, you have to bring the restriction. Restriction is you cannot have 0 when you want to divide. So find out for what value of x you get those zeros. You get for 5. So the domain is everything except 5. Any question? They may give you something a little bit more. So you may be given h of x equal to, you see on the top the x squared plus 7. They may give you x squared minus 4. Again, is a rational function. So we have to take care of the denominator. Denominator is x squared minus 4. So we have to factor it first. Okay, factor it first. You know that x squared minus 4 would be factored into x minus 2 times x plus 2. So we do the factoring first. H of x equal to, you see the bottom would be x minus 2 times x plus 2. The top, we don't care. You see now the number, we have two factors, x minus 2 and x plus 2. So the first one would be 0 at 2. The second one would be 0 at negative 2. So we have two numbers to exclude this time, okay? So this is your number line from negative infinity to positive infinity. So you have to exclude the negative 2 and you have to exclude the 2. Okay, because the denominator is going to be 0 at these two places. So what's going to be your domain, you see? 1, 2, 3. So the domain is negative infinity to negative 2, the first portion, union with negative 2 and positive 2, the second part, union with 2 and positive infinity. Okay, so it depends how many factors are going to have. In this case, you have two factors. You have two factors, so you have to exclude two numbers. You let this one equal to the 0, x would be either equal to 2 or x would be equal to the negative 2. So this is how we, how we get those two numbers. Any question? There is one more rational I talk about it, then there is a radical function we talk about it next time. So you may given this one. Let's see what is so special about this one. You see on the top, we get x squared plus x plus 1. But on the bottom this time, we get x squared plus 1. You see? It is a rational function. The numerator is x squared plus 1. So we try to factor it. But you know that x squared plus 1, you cannot factor it. We can factor x squared minus 1. So if you cannot factor it, you cannot let it to be equal to the 0. So this means this denominator is never 0. So the x is free agent. Okay? So solution, you have to mention that the x squared plus 1 is not factorable. Is not factorable. So it's never 0. Okay, so the number line stay the number line. So the domain of your function is going to be R. This function is defined everywhere. Any question? So it's a very nice argument, really. Get to know it, exactly know what we are talking about for this domain of the domain of the function. So that's a rational function. There is a radical function. We talk about it, next time, and we continue. We need one more lecture to be able to finish this very important section. Okay, any question? So look at the problem of this section. Some of them are tricky, 2.2. I'll go over some of them for you next time, but if you have any question, bring them in. There are a couple of more things to talk about it to be able to do the problems, but I do some of them because they are very important. Important section. Okay, I continue sorting out your quiz, okay, the assignment and etc. And then we are going to prepare you for your next test. That's going to be the one. Okay, question? That's it for tonight. Have a good night and take care. See you on
Thank you.
Wednesday.
Thank you.
Bye-bye. Have a good one. Thank you.
Night.
Bye-bye.